Welcome to the listening section of the TOEFL mock test, brought to you by Spinta. This section measures your ability to understand conversations and lectures in English. In this section, you will listen to several conversations and academic lectures. Each conversation and lecture is followed by a number of questions. You will hear each conversation or lecture only one time. You may take notes while you listen. You may use your notes to help you answer the questions. Some of the questions will replay part of the audio for you. Answer the questions based on what is stated or implied by the speakers. You must answer each question before moving on. You cannot return to previous questions in this section.
Good morning. Today we will examine ecosystem resilience and practical conservation strategies that aim to sustain ecosystem services despite increasing anthropogenic pressures. Resilience is a central concept in ecology. When I say resilience, I mean the capacity of an ecosystem to absorb disturbance and reorganize while undergoing change, so it retains essentially the same function and structure. That definition highlights two important elements. First is function, which refers to processes like nutrient cycling, primary production, and trophic interactions. Second is structure, which describes the physical arrangement of species and habitats. To illustrate, consider coral reef systems. During the bleaching events on the Great Barrier Reef, in 2016 and 2017, rising sea temperatures caused widespread loss of symbiotic algae. Reefs in some areas recovered their coral cover and species composition over a decade, and thus showed resilience. Other reefs shifted to algae-dominated states and lost key functions, such as reef building and fisheries support. So resilience is not the same as resistance. Resistance means avoiding change in the first place. Resilience accepts that change will occur, but asks whether the system can reorganize and continue providing services that humans and other species rely on. Several factors influence resilience. Biodiversity is often critical. Higher species diversity can provide functional redundancy, so if one species declines, another can fulfill similar roles. Keystone species can have disproportionate effects. For example, beavers alter hydrology by building dams and create wetlands that increase habitat heterogeneity and buffer droughts. Connectivity also matters. Habitat corridors increase gene flow and recolonization after local extinctions. However, connectivity can have trade-offs. Corridors may facilitate spread of invasive species or pathogens, so management must be adaptive. Human drivers such as habitat fragmentation, pollution, and climate change reduce resilience by simplifying ecosystems and removing species that provide critical functions. For instance, mangrove deforestation reduces shoreline protection and nursery habitat for fish, increasing vulnerability to storms. Conservation strategies therefore aim to enhance resilience rather than only protect isolated areas. One strategy is creating networks of protected areas with ecological corridors to maintain connectivity. Another is restoration ecology, where degraded sites are actively replanted or restructured to restore native species and functions. Assisted migration is an increasingly discussed tool. In this approach, managers move species or genotypes to areas predicted to remain suitable under future climate scenarios. This can maintain functional roles in ecosystems, but raises ethical and ecological questions about unintended impacts on recipient communities. Payment schemes for ecosystem services are a socioeconomic approach. Landowners receive compensation for maintaining or restoring habitats that provide flood control, carbon sequestration, or water purification. These schemes create incentives that align private interests with public ecological benefits. We also see examples where targeted species management increases resilience. The reintroduction of wolves to Yellowstone provides a classic example. Wolves reduced overabundant elk populations, which allowed vegetation along riverbanks to recover, stabilizing banks and altering stream morphology. Adaptive management is the recommended framework for implementing these strategies. It treats management actions as experiments, monitors outcomes, and adjusts policies based on new information. This iterative approach is essential because ecosystems are complex and our predictions are often uncertain. In summary, protecting and enhancing resilience requires a combination of protecting biodiversity, maintaining connectivity, applying restoration techniques, and using socioeconomic incentives. No single solution works everywhere, so context-specific strategies and careful monitoring are vital. For next week, please read the case study on mangrove restoration in Southeast Asia and come prepared to discuss the trade-offs between assisted migration and local adaptation strategies.
Listen again to part of the lecture, then answer the question.
When I say resilience, I mean the capacity of an ecosystem to absorb disturbance and reorganize while undergoing change so it retains essentially the same function and structure.
For more TOEFL mock tests, as well as IELTS and Cambridge practice, visit www.spinta.org. We provide updated tests every single day, AI feedback for your speaking and writing responses, and access to a wide range of high-quality mock tests to help you prepare with confidence.